Welcome students. In this session, we will look at the concepts of transfer learning. So what is transfer learning all about? We have already learned about convolutional neural network, but there was an issue as we saw in the previous classes. How many convolution layers or how many max pooling layers should I go for? There is no answer for that. But this transfer learning is trying to give an answer for that. So first let us go into what is the concept of transfer. What are we trying to transfer? And then we will club it with our CNN, and then we will have our advantageous model of CNN. Human beings always have the capability of transferring knowledge from one to another. It can be a task or it can be a domain. Say, for example, if you know to ride a cycle, you will know how to drive a car. Riding and driving, they have a difference in terms of whether the vehicle is motorized or not. So, if you know cycle riding, automatically that knowledge can be transferred. It will be easy to again drive a car. So, four possibilities are there as I have given here. It can be a same task, same domain, same task, different task, same domain, and different task, different domain. Option A and D are out of the box. We do not want to go into that because it is going to be done by anyone else. But the only thing which we are bothered about is same task, different domain. If we go for a classification, can I do something with the medical images? If I do with the medical images, is there any separate training necessary for lung image and brain image? Or whether I can put together these two things so I can say that my training is much more easier. In the same way, your different task and same domain, same lung image. If I go for classification and segmentation, should I train again and again? Because feature extraction is one of the important part which is going to judge the success of the subsequent steps. So these are some examples where you can see same task, different domain. We are going to classify, but the domain or the database are from different types. Five are there, triangle are there, circle are there. Still the process remains the same. If we know how to classify the triangles, we can easily classify the numbers. In the same way, different tasks, same domain, all are face images, but the names given to the face images are different. So if human beings can do B and C, how well does our deep learning approaches perform in these cases? So most of the methods such as CNN require large amount of data, which may not be practically available. And they are also specified to a simple task, one single task, which again depends on the nature of the application. If you want to have a different task, again you need to change the application. These two things can be called as the drawbacks of CNN. Our transfer learning concepts, how we transfer from one domain to another, can be used to make sure that our process is much more done in a simpler way. This is a pictorial representation of the conventional training and the transfer learning. The conventional training is on my left hand side. My transfer learning is on my right hand side. So you have the data set 1, you have the data set 2 and the learning task. The only difference here is you can find the difference in the size of the data sets. The first figure shows data sets which are of same size. That means if you do brain image classification, when you go for brain image segmentation, similar number of images or data are necessary. Suppose what happens if you do not have? So the answer is if you do not have, you can depend on the transfer learning concepts. So from the data set 1, because I have already done some processing with brain images, my features are already stored. So when I take another data set, say something close to the domain, another medical image, even though if the size is less, still I will be able to do the classification process because I can take the knowledge from the previous procedure. Now, what is this knowledge all about? Theoretically, it is knowledge, but practically speaking, it is nothing but the features and the weights which we trained using the stochastic gradient descent algorithms. What to transfer? Try to identify which is source specific and which is common to source and target. If you can make use of those things, then it is easy to go for the classification process. When to transfer? Make sure that you have images or data from the same domain. You cannot have the features of an aeroplane matched with the brain. That is absolutely impossible. So if you feel that these are from the same domain, then you can definitely do. How to transfer? Make changes in the existing algorithms with the help of this knowledge, and you can do. Now, how to implement the transfer learning? As we have seen in the previous algorithm, we found that CNN has two parts where we need to adjust the weights of the fully connected layer and also the initial filter parameters. Now, here we are freezing the filter parameters. This is nothing but the features of the brain images. So, if you are able to take features one time, why should you take again and again? That is the main concept of transfer learning. So use the same pre-trained network. There are plenty of pre-trained networks or features or weights which are trained with similar images are available. Take them and make some changes only in the fully connected layer. That means now you are necessary or it is necessary to adjust the weights of the fully connected layer only. Such type of pre-trained models plenty are available. Say for example VGG16, VGG19, Inception V3, Exception ResNet 50. Each varies in terms of their architectural arrangements. How many convolution layers, how many max pooling layers are fixed in this architecture. You can see that these models were trained for weeks before it is widely released in different types of software. Other models, VGG16 is with 16 layers, VGG19 with 19 layers, Inception V3 is with 48 layers, Exception more number of layers, ResNet 50, again 50 layers,